Good afternoon, ladies and gents. Welcome back to yet another exciting at VUT Engineering Electronic Labs. And in this tutorial, I would like to highlight a very simple guideline, if you may, of how to use a breadboard. Now, a breadboard is one piece of equipment that you are going to repeatedly use in almost every circuit that you will have to construct in the laboratory experiments. A breadboard is a special device that allows us to construct circuits without soldering. So it's a temporary circuit arrangement that we put in there. We can do a complete electrical analysis of that circuit, and then in the end we can disassemble it and start another circuit. So a breadboard is what we call it. A breadboard, we've got two types of models here by VUT. Some of them very nice with some color coding, and some of them more basic without the color coding. But in essence, they are the same. Now the beauty is I can do this. You will find a sticky part at the back. The sticky part is so that you can stick it onto the table. Careful, do not do it in the lab, because it will be there forever. The other part of the breadboard is, how does the circuit work? Remember, electric circuits, we have to connect legs to each other. For instance, if I now want to connect the LED to the resistor, one method is I can mechanically twist the legs together, and that way it will not fall off. It's a terrible way of doing temporary circuits, because now my legs is all over the place and they can touch, they can break each other. So if I remove it, I can have the components separately. And that is now where a breadboard unit is brilliant. Let me zoom in a little bit. A breadboard is isolated plastic with metal tracks inside. Metal tracks going up and down. If I use my pen there, and another line there, and another line there, and so on. You will notice, if I zoom in even more, haha, brilliant technology. You will notice that every row here has got a specific number, and it starts on one side from line number 1, and it is numbered A, B, C, D, E, F, J, giving me 5 on a side, and then in between here there is a valley. That is a completely isolated part, that there's no connection between those 5 holes and these 5 holes. So for instance, if I put something in F5 and I put the other leg of the LED into E5, the LED is still separate. If I bend it over for the video, this connection and that connection are not the same place. We use it very often when we use integrated circuits, whereby the top row of legs and the bottom row of legs are not to be connected, and that valley in the middle keeps them separate. So that works very well for us. The second part of the breadboard that is very relevant is this red and blue lines, whereby we have got little groups of 5 holes in 2 rows. The purpose of that is to give us power. And the idea is, this power of the circuit, we put it there, positive for your high voltage and minus, and at the bottom of the board, the same story, negative and positive. And you will notice, if I now have both sides, slightly out, that's it. If I have both on the screen, you will notice I've got nearest to the 5 pins my red line, nearest to the 5 pins at the bottom my blue line. That means I can now have a circuit that is positive and negatively powered, and the connections will run on this type of breadboard right through to the end. So this red and positive here is connected right through to the red positive there. The same for the blue, the same for the red and blue at the bottom. The convenience of that is Now I can make a circuit like the ones in the textbook. For instance, if I want to make a very simple circuit and say I have a circuit that is coming in at 5 volts, it needs to run through a resistor. There's a little resistor. Then I can put the resistor into the top red row, and I can put it into the corresponding row down here. In this case, I'm putting it into H25. Then I can take the LED, I can put the LED, the anode side, towards positive, the long leg, remember. I can put that one into F25, and I can put the cathode into E25. So if I bend it over for you guys like that, there. Then one can use a wire. There's a little wire. These little telecom wires works the best. Single thread, and with a bit of maneuvering, you stick it in there, and you find negative on the blue line. And after you've connected it, that is now a circuit positive through the resistor to the LED, to the other side of the LED, and the wire to negative. We encourage all the students to keep in mind that the positive is the red line, the blue is the negative line, or your zero, your common, and we encourage to orientate your breadboard in the way as shown here on the screen. If we construct a circuit like this, it would be like handing your textbook, but you are standing on your side all the time. And that will confuse the lab technician, and that will obviously bring down your marks when you look at quality work. Quality is very important when we make the circuit, because we need to be able to trace how good or how bad your circuit is, so that you can evaluate the quality. Sometimes you are given one of these breadboards. These breadboards do have numbers in the middle. They are still 5 pins connected parallel to each other like the previous breadboard, but they have no indication of red and black on top, and the same at the bottom. But if you now look at the way that this circuit is constructed, I'll zoom out for you to see the whole picture, then you will notice the components are such that the same line is used for that, the same line is used for this. From here, the components are arranged into the circuit, and we have the resistors coming down here. So in this case, the assumption is that this is a common rail, 0 volts, red is my positive, and for the electronics 3 guys, the minus 15 volt will go onto the green line. So again, the arrangement is very structured, it's very neat, and the idea of that is to do fault finding is very easy, because this circuit is now actually very close to the version that is in the textbook. Sometimes we have big components, in this case a multi-LED all-in-one unit, or you may have a display, and you can actually pull this thing out, and you will notice it's got legs, many of them. But when we put it in, we install it across the valley. Never try to do it like that, it will not work. The legs, there's nothing to conduct in there, so that would be a very silly idea. We would rather put it in properly, and sometimes a bit of mechanical force will keep it very steady. To summarize, breadboard must be structured. Always, from top to bottom, bottom to top, you have your columns, that is 5 at a time, and they are going from one side to the other side. The valley makes an insulated breach or valley then between the top 5 and this 5. You have a common rail that is for either positive or negative use. If you have color-coded breadboard like this, we prefer positive is positive, negative is the blue one, and the same for the bottom. On a closing note, be careful of these models without the lines. Let me explain. I zoom out slightly. You will notice 1, 2, 3, 4, 5 sets, and then this side 1, 2, 3, 4, 5 sets. Right here, there is no connection because this type of breadboard is broken or not connected in there. It's not broken like in faulty, but broken like in the circuit does not carry from there to here. So there it is not connected. The same at the bottom. And that means if I'm going to make a circuit on this arrangement like this power arrangement layout stops here. It doesn't cover to the second part. I have to put a wire bridge in this side in order to solve the problem. The same for these links here. And that, ladies and gentlemen, is the most easiest way of using a breadboard. Present it like this, arrange your circuit so that it makes sense. Try to build it as close as possible to the circuit in the textbook or in the task that you have to do, and that way you are guaranteed that your circuit is going to work. Thank you very much.